Hello everyone, welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are getting ready to start Chapter 5, Lesson 2. In this lesson, we are going to work officially on factoring by grouping, which is a topic that I introduced to you in Section 1. If you recall from Section 1, I taught you that when you have a group that is identical in each one of your terms, you can consider that group to be a GCF within your expression. This is a special type of factoring that we call factoring by grouping. And this type of factoring is used specifically whenever we have 4 terms. So what we're going to do now is do exactly what we did in Lesson 1. When you identify that you have that common group that exists in both of your terms, you bring that group down into the next line and you create a new group. The terms of the new group will come from what was left over in the original expression. So we bring down the x and we bring down the positive 2, and those terms are put back together in order to form a second quantity. You scan those terms to make sure that they don't have any common factors that can be brought outside of those quantities. Ours does not, and we are finished. That is the answer to this problem. A special note here that this can also be written as x plus 2 times x minus 3, and the answer would be correct. Please remember that multiplication is commutative. You are permitted to multiply in whatever order you want, and you would still get the same answer. So you can write your terms however you wanted to. Example 2 looks very different, doesn't it? It's actually going to be solved the same way. However, this is where the 4 terms by grouping comes into play. You often will have an expression that's written like this that you will see and you might think, I'm looking across this expression. There is no GCF between 2, 3, 6, and 9. Not every single term has an x. I can't factor, but we can. And the way that you factor when you have 4 terms is you want to go ahead and throw some parentheses around your first 2 and your last 2 terms. Let me slide that back up where it belongs. Okay, once you get your parentheses written around your first and last 2 terms, you are then going to factor out the GCF of each group. So as you look at the first group that I made, you should see that we can factor an x out of that group. So I'm going to go ahead and do that now. If I factor an x out, and remember factoring is like dividing, so 2x squared divided by x leaves me with 2x, and 3x divided by x leaves me with 3. Remember, we're just pulling that x out front. You're then going to look at your second group and say, what's the GCF of those 2 terms? What's the GCF of 6x and 9? What can I divide out of both 6x and 9? Well, they're both divisible by 3. So we're going to go ahead and factor out a positive 3. 6x divided by 3 leaves us with 2x. 9 divided by 3 leaves us with 3. When you do this correctly, you should create groups that are identical. If you have not created groups that are identical, then something did not work correctly. Once you have created those identical groups, then you pull that group down into the next line, and we're going to create a second group out of the items that are left over, which are the x and the positive 3, so they make their own group of x plus 3. You always, always, always want to scan your groups to make sure that nothing more can be factored out of them. Can we divide anything out of 2x plus 3? No. Can we divide anything more out of x plus 3? No, we can't. So at this point, that is our final answer. Let's take a look at another example. Remember, we always want to start by taking parentheses and putting them around the first two terms and the last two terms. When we have 4 terms like that and we see that there's nothing that we can factor out of every single term, we can use factoring by grouping. So we want to identify the GCF of my first group. What can we divide out of 4x plus 8y? We can divide out a 4 from both of those terms. 4x divided by 4 is x. 8y divided by 4 leaves us with 2y. In the second group, when you look at them, we want to identify the GCF of that group. They both contain an a, so we will factor out an a. Ax divided by a leaves us with x. 2ay divided by a leaves us with 2y. At this point, you want to check to make sure that you have created identical groups. If your groups are identical, then you can drop it down into your next line and prepare to create a new group from what was left over. 4 plus a. Always scan that line to make sure that there are no common factors remaining within the parentheses that you have created, and as long as there are none, then you have the answer. Example 4. As we look at this one, it has 4 terms, but if we were to slap some parentheses around the first 2 and the last 2, would we be able to take out a common factor? Is there anything common between bx and 4y? Is there anything common between 4b and xy? There's not. But man, as we look at those letters and numbers, it sure does look like we could make something work, because we have a couple of x's, a couple of y's, a couple of b's, and a couple of 4's. There has to be something that we can do with this, right? What you do in a situation like this is try rearranging your terms. I'm going to put bx plus 4b beside each other, and then I'm going to put xy plus 4y beside each other. The reason I chose to do that was because I thought that my b's would go good together, and I thought my y's would go good together. I'm just going to try this out. So I'm going to go ahead and put some parentheses around the first 2 and the last 2. Do I have a GCF now in my first group? I sure do. I can take out a b. When I factor out that b, I'm left with x plus 4. Do I have a GCF in my second group now? I do. It's y. When I factor out that y, I'm left with x plus 4. Do my groups match? They sure do. Since my groups match, I'm allowed to drop it down and create a new group from what's left over in my line of b plus y. As you're rearranging your terms, please remember that the sign in front of them belongs to them, and we're permitted to do that because addition is commutative, and we're allowed to add in whatever order we want to, and that won't change the value of our final answer when we get there. So we were allowed to rearrange the terms here in this line, which helped us to factor by grouping in the rest of the problem. All right, let's take a look at example 5. I would like for you guys to go ahead and try this one. There's nothing tricky about example 5. You don't have to do any rearranging or anything like that. Just go ahead, give it a shot. Please pause the recording, try the example, and as soon as you're ready, please press play and we'll go over the answer together. Okay, at this point you should have had an opportunity to factor example 5. So you should have started by putting some parentheses around the first 2 terms and the last 2 terms. We are going to start by finding the GCF of my first group. There's nothing that we can divide out of a 2 and a 5, but we see that they both contain at least one x. So I'm going to go ahead and factor out that x. That's going to leave me with 2x plus 5. In the next group, I have negative 4x minus 10. Now remember, our goal is to factor out some type of number or variable so that I will create a group identical to 2x plus 5. Both of these terms are negative, and I need to make them positive. Through division, the only way to turn a negative into a positive is to divide by a negative. So I'm going to have to factor out a negative number. Now, I can divide out a 2 from both of my terms. So if I factor out a negative 2, that should flip both of my signs to positive, and I should, in theory, end up with the same group as long as I've done my work correctly. So negative 4x divided by negative 2 leaves me with positive 2x. Negative 10 divided by negative 2 leaves me with positive 5. We now have exactly the same group, so we're allowed to drop it into our next line and prepare to write our last group, which will come from the remaining terms of x and negative 2. So the second group is x minus 2. Always check to make sure that you have no other factors that can be factored out of either quantity. We do not, so our answer is complete. Please go ahead and try example 6. Please pause the recording. As soon as you're ready, we will check our answers together. Okay, by now you should have had an opportunity to complete example 6. You should have started by putting some parentheses around 2ax and negative 2bx and positive b. Slide that back up there every once in a while. It moves itself down. Once you have your parentheses in place, you're going to look for the GCF of each group. The GCF of the first group is A. So we're going to go ahead and factor out that A. And that's going to leave us with 2x minus 1. Remember that factoring is like division. So if you have A divided by A, that leaves us with 1. In the next group, please remember that your goal is to create an identical group to what we have in our next line. So we have a positive 2 and a negative 1. Up here, we have a negative 2 and a positive 1b. Our signs need to flip. We learned in the last problem that in order for the signs to flip, we have to take out some type of negative. And they both contain a b, so we are going to divide out a negative b, or factor out a negative b. So completing that factoring, when we factor out that negative b, and remember it's like dividing, negative 2bx divided by negative b leaves us with positive 2x. Positive b divided by negative b leaves us with negative 1. We have now flipped our signs and we have created an identical group which can be dropped down into our next line. We will make a new group with everything we had remaining, which gives us A minus B. We want to check to make sure that nothing further can be factored out of those groups, so just check for a common factor between 2x minus 1. There is none. And A minus B, there is none there as well. So we're going to go ahead, call that our final answer, and move on to example 7. Please pause the recording, complete example 7, and as soon as you're ready to check your work with me, please press play, and we'll go over your answer together. Okay, by now you should have had an opportunity to complete example 7. If you were to put parentheses around your first two terms, would we have a GCF to remove? No, we don't. Let's look at our next two terms. If I put a parenthesis around those, do I have a GCF to remove? Well, I could take out a 2. I don't think that's going to get me where I need to be as far as my factoring by grouping is concerned. So I'm going to consider rearranging these terms because I see that I do have two terms that contain a D, two terms that contain an A, two terms that contain a B, two terms that contain a C. My numbers as well are going to be compatible. 21 and 28 are both divisible by 7, for example. 8 and 6 are both divisible by 2. So I would probably want to rearrange my terms thinking about that compatibility. So I'm going to write 8AD minus 6BD. This choice allows me to have my 8 and 6 together because they're both divisible by 2. And this should be a D, sorry. I have both of the terms that contain a D written together as well. Then I will have my 21BC minus 28AC as my last two terms, giving me the 21 and 28 that are compatible and the C's as well. So now I'm going to put the parentheses around the first two and the last two and say, what can I divide out? 8 and 6 are both divisible by 2. and they both have a D. So I'm going to remove a 2D. 8 divided by 2 is 4. And then I have divided out that D, so that leaves me with 4A. Negative 6BD divided by 2D leaves me with negative 3B. For my next group, 21 and 28 are both divisible by 7, so I'm going to factor out a 7, and they both contain a C, so I'm also going to factor out a C. All in all, we're factoring out a 7C. So 21BC divided by 7C leaves me with 3B. Negative 28AC divided by 7C leaves me with negative 4A. Man, my numbers are so close in my quantities. They're not quite the same, are they? Here, I have a positive 4 and a negative 3. But in this group, I have a positive 3 and a negative 4. It's not quite right. What did we learn that we could do in order to flip signs? If we were to have taken out a negative 7, 21 divided by negative 7 would have given me a negative 3, and negative 28 divided by negative 7 gives me a positive 4. I now have identical groups. Remember that addition is commutative. You can flip-flop those numbers and they'll mean the same thing. So I'm going to bring that group down, 4A minus 3B, and I'm going to get ready to write my new group, which will come from 2D and negative 7C. So my new group is 2D minus 7C. I'm going to check both groups to see if there's any common factor that can be factored out of each group. There's not. This is my final answer. When a situation like that arises for you and your signs are off, and that's the only thing that's off are those signs, those positives and negatives. Take out a negative, divide out a negative. That will always reverse your signs. If you have any questions at all about what we covered in this section, please feel free to contact me and I will be more than happy to set up tutoring with you or answer your questions however you need me to. Thank you.